Hello and welcome to this presentation from the Urban Penguin. My name is Andrew Mallett and today we're looking at that problem that you do want to create reusable code, but you need to know how to make it reusable across all of your projects within Python. So we're going to be taking a look at modules and taking a look at packages and looking at the difference between the two of them and seeing how we can set it up in our development environment. Now, come on then, take a look at my working environment. Yes, I know it is Windows, but many people will be using Windows as their software development platform. We'll be taking a look at using Python and Visual Studio Code, all of which are available on macOS as well as on Linux. So everybody should be able to follow through and get the most out of this exercise. I've just created a projects directory on my desktop with two empty subdirectories, P1 for Project 1 and P2 for Project 2. We're going to be looking at working with modules and packages inside of our P1 directory to begin with. Moving through to Visual Studio Code, we can navigate through to my desktop, projects, and I'm going to open up the empty Project 1 directory. So the project directory is shown then at the top of my Explorer. Let me just clear that warning about trusting the author. And this will then contain all of my configuration, my packages, and my modules. And we're going to be stepping through the process. The first thing that we're going to do is create ourselves a Python file so we can identify what type of project that we're working with. So I'm just calling this main.py. Now, taking a look at the bottom right-hand corner of Visual Studio Code, we can see then the version of Python that we're using for this. And this is our global or system Python. Ideally, we don't develop our projects with our system Python. If I go through and open up a terminal, so if I just go View and Terminal, we can wait for it to open up as it builds the first time. If I do a pip list, I can list all of the modules that we have. And these are representing not my project modules, but the modules and packages that have been installed into the system. As I work on more and more projects, it's going to be very difficult to differentiate the packages required for my project from the packages that I had anyway. So working in a clean environment is going to lessen the overhead on your system Python, as well as making it easier to determine what is required. So I'm just going to close this down. I can just kill the terminal with the dustbin. Go back onto the versioning in the bottom right-hand corner and create a virtual environment based on VMenv. And I can choose then to clone my global Python interpreter, but we don't bring across any of the additional packages. We only have the packages that are built into Python. Once that has set up, I have got a clean and fresh environment. And if I go back through to my terminal now, it tells me that the virtual environment has been created and activated, but I don't see a VM in front of the prompt name. But I can verify by running pip list, and we can see now that it's a very different view. We've only got the Python installer pip as an available package. So this is a great starting point, a clean and fresh Python environment for a new project. The next stage is to understand the term module. In reality, any Python file is a module. But let's just go through and check that my main py file, my main Python file is working. And we can see there that we're printing hello. I probably clicked it twice, but I've got hello coming out twice. So my virtual environment is up and running. I can see then the Python interpreter coming from my virtual environment, and everything is working well. But to investigate the concept of modules a little bit more, I'm going to go through to my P1 directory and create a new file. I'm just going to call this, I don't know, it doesn't really matter what. Let me just call it simple.py. We'll have a function inside of this, so define. And then we can have something like, say, hello. I'm going to keep this really simple for the demonstration, so I'm not putting in any type hints. And then we can have good day to you. And of course, all of this needs to be in quotes. So let me select the text and add in my double quotes. So I would normally use double quotes for quoting text, although it makes no difference to Python. But you should be consistent. Keeping the consistency is important. I'm actually going to save this. I know you don't normally need to save files because you run it, it's going to be saved. But I'm not really going to run this file. I'm going to reference it from my main PY. So don't forget to save your simple PY file, the module. We can now see my import working. So from simple, import, say hello. So simple now we can see is a module, but there's nothing special about that. I can execute my main PY without saving it specifically because it saves when I execute. Of course, the import worked, but I didn't actually call say hello. So let's just add that in. And then, of course, we get hello and good day to you. So in simple terms, a module is just a Python file, any Python file that we can access. So this is within my home directory, or the same working directory rather. This is in my working directory, so I can access it. If it wasn't in my working directory, I couldn't navigate back up my structure to be able to read it. We're going to create now a new directory, and I'm going to call this utils. Utils is going to act as a package. A package is a container for modules. So a module is a Python file. A package is a container or directory that contains Python modules. I'm defining then add numbers. So again, a very simple function. We'll just have A added to B. Again, not worrying with type hints and returning A plus B. Would seem reasonable if we've called it add numbers, don't you think? Again, not forgetting to save then my add.py file. I can move back into my main file now. And I go from, and then my package name, utils, navigating down to the module.add, so utils.add, import, add numbers. Now we can quickly test that this is going to work, so I can use the print statement and then add numbers, and we can then go through and add 3 and 2 together, and hopefully if my maths are right we're going to get 5. So I get hello, good day to you, and we have 5. Utils now is acting as a package, a container for modules. But very often, you know, when you import a module, you're accessing the resource directly. And that would be done by making the utils directory appear as a Python file, a module itself. If I go through to utils, and I'm going to create myself a new Python file, but this file has to have a very special name. So dunder init.py. That's double underscore init double underscore dot py. The dunder init file. It's the dunder init file that makes the directory appear as a module itself. So again, I can put as many resources inside of my dunder init file as I want. So here I'm just going to go through and put in one function. We might as well have sub for subtract numbers. Again, keeping it really simple, and then just returning a subtract B. And with that done, don't forget to save the dunder init py file. So let's go up and save it. And now returning through to my main.py. From here, I can go through and we can check the import is working okay. So from utils directly, I can then import sub numbers. I don't need to navigate down to utils.dunderInit. DunderInit is making the utils directory appear as a module itself. But either way, utils is a directory, so is always a package, a container of modules. It can have separate modules, or it can be made a module itself by creating the dunderInit.py file. Remember, dunderInit is _init_.py. The next stage is to go through and take a look at building a package that we can distribute to other projects, be it locally or through the PyPy repository. So I'm creating a new file here called pyproject.toml, T-O-M-L, so pyproject.toml. I'm going to copy across an existing template that I use. So I'm just going to drop out, copy this across, and then paste it in. The pyproject.toml file has been in place since PEP 518, and as we go through and take a look at it, we can see, well, when we build packages, what do we require? We can give our project a name, and we can then go through and specify my-package. I'm setting up a name deliberately different to our directory, our utils directory. As we scroll down, we can see then the dependencies. So this is replacing the requirements.txt. This really becomes a single source of truth file that we can work with. It's replacing the requirements.txt, but it's also replacing the setup.py file that was previously used before PEP 518. Now we specify when we run setup what packages we want to search. And I'm going to look for the utils directory, but this would be a list of subdirectories that had the dunderInit.py file in it. So we've only got the one directory, and I'm going to go through and save the toml file. I'm going to go through now, and in my project, I'm going to install build, setup tools, and wheel. We said that build requires this, but I have to have the build module in any case to be able to do anything with it. They're going to be installed in this project, but they don't become requirements of the target project. With these installs, I can actually now just go through and execute Python and build myself a package that I can use in my second project, P2. As I run through, then Python -m and build. We read the pyproject.toml file, and we're creating in the distribution directory the output. And it will give me the wheel output, which is my standard pip install, as well as a zipped up version, the tar.gz file. So this now has created a package that I can share with other projects or even publish to the PyPy site. Now, of course, I know you want to see this working, so let me go through and just close this folder and open up the project2 folder so I can navigate through to my desktop, projects and project2. Again, it's an empty folder. I can trust the authors again. And the first thing I'm going to do is create myself the main.py file so I can identify this as a Python project. Having now created my Python file, I can create a virtual environment, basing it on then my global environment as we did before. We can allow this to run through. So this again is going to give me that clean Python environment with only pip installed. That's now done and is up and running. And if I go through and open up my terminal, we should be able to see through here with pip list only one package. So we see there that we have pip. So this is pretty much where we had things before. But what I'm going to do now is a pip install, moving to the parent directory, so ... and then navigating down to P1 and distribution, and then just tab completing then on my package, making sure that I've got the wheel file. And we can see then that we've installed my package, and I can do a pip list, and we can see then that my package, remember that's the name that I gave to the package. It's not the name of my module. Remember, I might have many subdirectories within that. So we would then go through and use from the utils module. We can navigate down and import my subnumbers. So this is coming from the dunder init. And then we can prove that it's working through to the add py utils.add. And we can then go through and see import and our add underscore numbers. We want to check that both of these are working, so both can be imported and can execute correctly. So we will add in the simple print statements, but we've imported all of our packages, but not the modules at the top level. So we didn't have our simple module or our main module. So now as I go through and print sub numbers, and we can have 9 minus 1, and then maybe if we do almost the reverse of this, at least we know the maths are working nicely. Let's have our add numbers, and then 8 plus 1. And this should be good to go. Let's execute it. And as we look at the glorious output, we can see then that we've got 8 and 9. So that is looking good to me. So when you think of it, we created our package from our first project and made it available to our second project by importing or installing the package. We've shown what a package is, a collection of modules in a directory, and the use of the dunder init Python module. So working through a quick summary, you will have your project directory. Inside of your project directory, we can create the pyproject.toml file that then incorporates the requirements.txt as well as the setup.py file, all of it in one file. We then create packages within our project directory. Packages are directories themselves, but these directories contain other modules. One such module could well be the dunder init module that represents the directory or package itself. As well as the dunder init module, you can also create other named modules inside of your package directory.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.